Good morning to everyone. Myself is Devi, Assistant Professor, Department of Artificial Intelligence and Data Science. I am going to teach the subject structures using C++. Today we are going to discuss about the topic insertion sort. Insertion sort is a symbol sorting algorithm that builds the finalized sorted array one element at a time. It works on the principle of that starts from the second element, it compares with the previous element, and it shifts the element one position to the right, insert the current element in the correct position, and this process is repeated until all the elements in the array become sorted. It is easy to implement. It is efficient only for smaller data set. Consider 6 elements in an array. It ranges from 0 to 5. 6 is the first element in the array, and third is the last element in the array, where the array is unsorted form. The sorting begins with the second element, and the second element is compared with the first element. When the second element is smaller than the first element, the swapping takes place. That is, the element is swapped. Small element is placed in the first position or the zeroth index. Consider the third element, compare it with the second element, which is greater than the third element. Now swap the second, third element, compare the fourth with the first element. The fourth element is greater than that of the first element, so we need to swap. The next pass, consider the fourth element, that is 2. It is compared with the sixth element 6, where 2 is smaller than the element 6, so swapping takes place and it is placed in its correct position. That is the second position. Then take the fifth element. That is the 5 is compared with the 5 is compared with the previous element 6, which is already sorted, but 5 is smaller to 6, so it should be swapped. Place it in the fourth position. Take the last element, that is 3, that is compared with the previous element, that is sixth element, greater than the element 3. Similarly, compared with the previous element until the element is placed in its correct position. All the elements is compared and sorted until it is placed in its correct position. At last we will get the sorted array, that is 1, 2, 3, 4, 5. The time complexity of this algorithm is, in the case of best case, order of n, which is already sorted, and average case is order of n square, and the worst case is order of n square. The case complexity is order of 1. The advantage of this algorithm is simple to implement, efficient for smaller datasets, stable sort, works well for nearly sorted array, and the disadvantage is it is inefficient for larger dataset comparing to the algorithm like merge sort or quick sort. This is all about the insertion sort. We will see the next topic in the next section. Thank you.